Hello again, this is Bob Tejada, Netcons Consulting. In this session, in this tutorial, we are going to talk about long-term evolution. What is long-term evolution? In telecommunication, long-term evolution is a standard for high-speed wireless communication for mobile devices and data terminal based on the GSM H and UMTS high-speed technologies. I explain it. GSM H and UMTS HSP are acronyms that for General System of Mobile Communications, Enhanced Data for GSM, Ultra-High Mobile Telecommunication Service, and High-Speed Packet Access Technologies. It increases the capacity and speed using a different radio interface together with core network improvements. The standard is developed by the 3-generation partnership project and is specified in its release number 8 document series, with minor enhancements described in release number 9. Long-term evolution is the upgrade path for carriers with both GSM and Universal Mobile Telecommunication Service networks and code-division multiplexing access 2000 networks. I repeat, it's the upgrade path for carriers with both GSM UMTS networks and CDMA 2000. The different long-term evolution frequencies and bands used in different countries mean that only multi-band phones are able to use long-term evolution in all countries where it is supported. Long-term evolution is commonly marketed as 4G long-term and advanced 4G, but it does not meet the technical criteria of the 4G wireless service as specified in the 3-generation partnership projects, release number 8 and release number 9 series for long-term evolution advanced. The requirements were originally set forth by the International Telecommunication Unit Standard Organization for IMT Advanced specification. However, due to marketing pressures and the significant advance that WiMAX evolved, high-speed packet access and long-term evolution bring to the original third-generation technologies. International Telecommunication Unit later decided that long-term evolution together with the aforementioned technologies can be called 4th-generation technologies. The long-term evolution advanced standard formally satisfies the requirement to be considered a IMT advanced. To differentiate long-term evolution advanced and WiMAX advanced from current 4th-generation technologies, International Telecommunication Unit has defined them as true 4th generation. Much of the long-term evolution standard addresses the upgrading of 3-generation UMTS to what will eventually be 4th-generation mobile communication technology. A large amount of the work is aimed at simplifying the architecture of the system as it transitions from the existing UMTS circuit plus packet switching combined network to an all-integrated protocol flat architecture system. European Ultra is the air interface of long-term evolution. Its main features are: 1. Peak down rates up to 300 megabits second and upload rates to 76 megabits seconds, depending on the user equipment category. 5 different terminal classes have been defined, from a voice-centric class up to the high-end terminal that supports the big data rates. All terminals will be able to process 20 MHz bandwidth. Low data transfer latencies, sub-5 microsecond latency for small Internet protocol packets in optimal conditions. Lower latencies for handover and connection setup time than with previous radio access technologies. Improved support for mobility, exemplified by support for terminals moving at to 350 kilometers per hour, 220 miles per hour, or 500 kilometers per hour, 310 miles per hour, depending on the frequency band. Orthogonal frequency division multiple access for the downlink, single carrier FDMA for the uplink to conserve power. Support both frequency division and time division communication system, as well as 5 duplex frequency division with the same radio access technology. Support for all frequency bands currently used by IMT system and ITUR. Increased spectrum flexibility, 4 MHz, 3 MHz, 5 MHz, 10 MHz, 50 MHz, and 20 MHz. Wide cells are standardized. Wideband code division multiplexing access has no option for other than 5 MHz slices, leading to some problems rolling out in countries where 5 MHz is a commonly allocated width of a spectrum, so would frequently already be in use with legacy standards such as 2nd-generation GSM and CDMA1. Support for cell size from tens of meters radius, femto and picocells of 200 kilometers, 62 miles radius microcells. In the lower frequency bands to be used in rural areas, 5 kilometers, or 3.1 miles, is the optimal cell size. 30 kilometers or 90 miles having reasonable performance, and up 200 kilometers cell size supported with acceptable performance. In the city and urban areas, higher frequency bands are used to support high-speed mobile broadband. In this scale, cell size may be 1 kilometer or even less. Support of at least 200 active data clients in verified megahertz. Simplified architecture. The network side EUTRAN is composed only of eNode BS. Support for interoperation and coexistence with legacy standard GSM, Edge, UMTS, and CDMA 2000. Users can start a color transfer of data in an area using a long-term evolution standard, and should coverage be unavailable, continue the operation without any action on their part using GSM, GPRS, or WCDMA-based UMTS, or even 3rd-generation partnership project number 2 networks, such as CDMA1 or CDMA 2000. Packet switch radio interface, support for multicast broadcast single frequency network. This feature can deliver services such as mobile TV using the long-term evolution infrastructure, and is a competitor for DVB-H-based TV broadcast. Only long-term evolution compatible devices receive long-term evolution signal. Voice calls. The long-term evolution standard supports only packet switching with all its Internet protocol network. Voice calls in GSM, UMTS, and CDMA 2000 are circuit switched. So with the adoption of long-term evolution, carriers will have to re-engineer their voice call network. 3 different approaches sprang up. 1. Voice over long-term evolution, which is circuit switches fallback. In this approach, long-term evolution just provides data services, and when a voice call is to be initiated or received, it will fall back to the circuit switch domain. When using the solution, operators just need to upgrade the MSC instead of deploying the IMS, and therefore it can provide services quickly. When I say MSC, what I mean? Network switching system. That is the network switching system. That is the technology that enable the communication of voice call in long-term evolution. You follow me? So let's proceed. As I told you before, we have also, when using this solution, operator just need to upgrade the MS multi-switch connection instead of deploying the IMS. When I say IMS, what I mean? IMS, Internet Protocol Multimedia Subsystem, which is the architectural framework for delivering Internet Protocol Multimedia services. Remember that every communication in long-term evolution is packet switch. And when you use a voice call, you must apply those technologies in order to enable the communication of the voice call. So let's continue. To ensure compatibility, 3rd-generation partner projects demands at least a special codec of narrowband. But the recommended speech codec for VoLTE, voice over long-term evolution, is adapted multi-rate wideband, also the high-definition voice. This codec is mandated in 3rd-generation partnership project networks that support 16 kHz sampling. Fraunhofer IIS has proposed and demonstrated full high-definition voice and implementation of AACL, Advanced Audio Coding Enhanced Low Delay Codec for long-term evolution handsets, where previous cell phone voice codecs only supported frequencies of 3.5 kHz and upcoming wideband audio services branded as high-definition voice of 7 kHz. Full high-definition voice supports the entire bandwidth range from 20 Hz to 20 kHz. And frequency bands. Long-term evolution standard covers a range of many different bands, each of which is designated by both a frequency and a band number. North America 600, 700, 800, 850, 1700, 1900, 2300, etc. Latin America, Caribbean 700, 900, 1700, 1800, etc. Europe 550, 1700, 800, Asia, Africa, Oceania, etc. As a result, phones from one country may not work in other countries. Users will need a multi-band capable phone for roaming internationally. Well, by the time being, that's going to be all for the long-term evolution. I see you in the next chapter. Thank you very much. Don't forget to give us a thumbs up in this video clip. Thank you. Have a nice day.